Okay, this is chapter 1.5, example 1. Approximate radiation levels in millirads per hour, that's just how you measure radiation, near the Fukushima nuclear power plant in Nara, Japan, are shown in the table below. If you remember the name Fukushima for whatever reason, that was the power plant that almost went critical a few years ago when the tidal wave came in. But here we go. Use the data set to determine if the relationship is linear or exponential. Well, really quick, we can figure out if it's linear. Again, you always check the left side just in case. So all of these, we'll notice that we're going up by 1. It says 0, 1, 2, 3, 4, 5, 6. So we're going up by 1 right there. Okay, always check it. And on the right, we just start subtracting. So 39.8, 39.8. Helps if I type it in right. 39.8 minus 71.2. So we're going down 31.4, 22.3 minus 39.8. We're going down by 17.5. That's a huge difference. I'll do one more just in case. 12.5 minus 22.3, 9.8. Yeah, I'm going to stop there because it's one thing to be off by a little bit. These are way off. So I'm going to erase those, and we'll try ratios. So if it doesn't add up the same, if it's not the same plus or minus, it's not linear. So we'll try the ratios. So 39.8 divided by 71.2, we get 0.5589. So I'm just going to do I'm going to do 3 decimal points for this point. So that's times 0.559. 22.3 divided by 39.8. We also get 0.560 times 0.560. Yeah, that's much closer. 12.5 divided by 22.3. We get 561. Good. Times 0.561. 7.1 divided by 12.5. We get 0.568 times 0.568. And if you haven't realized it by now, these are all very, very similar. Let me fill out the rest real quick. Okay, there you are. Those are all your ratios. And hopefully you immediately notice that these are so much closer to each. They're all 0.5s. It's like 0.55, 0.56, 0.56, 0.56, 0.54, 0.56. They're all really, really close. So what we need to do is find an average ratio. So add them all up and divide by what? We've got 1, 2, 3, 4, 5, 6. We have 6 of them. Divide by 6. One thing I've noticed is I had a lot of people for chapter 3 with the linears that we did this way, they would go, oh, well, there's 7 data points, divide by 7. No. There are 7 ratios. There's 7 differences. So we need 6 differences, 6 ratios. So when we do the average, we need to divide by 6. So add all up, divide by 6, 0.59, and give me just a second to do that real fast. And after I do all that, I find the average to be the average ratio to be 0.560 according to what I just did. So again, we add them up, add, and divide by the number there are. So in this case, there were 6. So we have enough to write our equation. So in this case, y equals 71.2 times, that's your starting point, remember, times 0.559 to the x. And that would be our ratio. And if you scan down the page a little bit, you would realize that's exactly what they did. We start off here. Discard. They start off here, they tell you to take all, they said, hey, let's subtract them first. And they got the exact same numbers that we did. We got 31.4, we got 7.5, we got 98, negative 5. We just didn't go as far because we realized this isn't working. Okay? So let's scan down, close. They tried the ratios, and look, they got the exact same ratios that we did. And when they kept on going, they said, hey, oh, they just determined, they didn't write the equation. Oh, slackers. Whatever. So we've got those guys right there. We added them up and divided by 6. So we got the average and we wrote it. Go ahead and try. You try me number 1. This is example 1. Go ahead and try me number 1. All right, for you try me number 1. A Major League Baseball player's average in successive seasons is recorded by the table. Determine if it's linear or exponential. Well, because this is an exponential, we can try the exponentials real quick. But I'm going to start off by trying out the linear. So we got to try if it's subtracting or adding. So 0.242 minus 0.213, that's 0.29029. 0.271271 minus 0.242, that's 0.29. 0.301 minus 0.271, that's 0.3. 0.330 minus 0.301, that's also, also 0.330, 0.30, not 301, I'm sorry, not 309, 301, is also 0.029. And then last but not least, 0.359 minus 0.330 is 0.029. Oh wow, I guessed wrong. So this one's linear, all right? Because it's got the same addition on both of them, it's linear. All right, those are identical for all practical purposes. So if you wanted to get the equation, basically add them all up, divide by what, 1, 2, 3, 4, 5. So divide by 5, and we'll get the equation. So let's do that real quick. Add them all up. 0.029. There's 4 of them. So add them up 4 times plus 0.03. We get 0.146, and divide it by 5. And we get an average of, who would have thunk it, 0.0292. So I'll use 0.029 as my ratio. So y equals 0.029x plus my starting point, 0.213. And that would be your equation.